and today I'm very happy to have our IoT antenna session with Ignion. So today with Ignion we will do a live IoT antenna integration demo. And our speaker of today is Jordi. Jordi is an antenna and product engineer at Ignion, and he will walk us through about the virtual antenna technology of Ignion and the history of IoT antennas, and then he will show us how to do an IoT antenna integration in real life.
Thanks, Ansep. Well, hello everyone, and welcome to this IoT Creator webinar. Let me introduce myself again, please. This is Jordi Miró, antenna and product engineer at Ignion, working in radio frequency for more than 4 years. Here in Ignion, I work in the product development team, developing applications with our antenna portfolio, from sub-gigahertz frequencies up to 10 gigahertz frequencies, with applications such as GNSS, ultra-wideband LTE, and the ones that are related with these learning creators week, LTE-M and LoRaWAN IoT as well. And well, let me share my screen before starting. So today we will talk about how to get the best signal quality in your IoT device, thanks to Ignion technology and making IoT design easy for you. Before starting, probably here there are some engineers that are involved in the design of IoT device. And most probably you have faced some of these top 3 challenging issues when you are integrating an antenna. Even you have faced some issues choosing the right antenna component between a list of 100 or more than 100 antenna components in the market. Then once you have selected the antenna component, maybe you have faced some issues integrating and tuning the antenna in the selected frequency band for your application, and also planning resources for this antenna integration with your engineering team. So, well, you would like to hear each of these issues will be solved in this webinar with our reduced antenna portfolio and proficient technical team, and each of the steps from the initial design of your device to the final device. The antenna integration will be easier than ever. So we're going a bit deeper into the antenna evolution context in the IoT domain. In the 20s, as you may know, we have our devices with external antennas. And as the first inflection point in time in the 2000 approx, we developed, we passed from external antennas to internal antennas, miniaturized and multiband. But these antennas, these internal antennas, the control was they are complex, has geometries complex and form factors also customized for each of the device, so it can be reused. So the second inflection point in time was the creation of the virtual antenna technology, 10 times smaller than previous internal solutions, and but able to fit in any IoT device. So it can be used on any of your device for different projects, and also able to fit into any IoT band. So to sum up, virtual antenna is an off-the-shelf antenna that can be integrated in any IoT device covering any protocol, not only the ones that are related to this learning week, but also GNSS, LoRa, ZigBee, Bluetooth, so on. Ignion has a really reduced antenna portfolio with only 6 antennas, but despite this, we are able to cover from 400 megahertz frequencies up to 10 gigahertz frequencies. This reduced antenna portfolio allows the designer to select easier than ever the antenna component, no matter what is your wireless technology that you must need for your device. From the nano extent, the smallest antenna we ever had in our company story, able to cover from Bluetooth to up to 10 gigahertz frequencies, to the Trium extent, the largest one, but also the more versatile, able to cover sub-gigahertz frequencies up to 800 megahertz. Then, if you need to further know about our products, I will invite you to visit our website in the product session to see as well the Duo, the One, the Run, and the All extent, and you may choose that better fits your requirement and needs in terms of design constraints. To explain a bit more about our antenna technology is based on 3 main elements. We have the virtual antenna that fits every IoT product that you have seen in our portfolio. And then we have the matching network to tune the antenna response in the selected frequency band. And also we have the ground plane as the main radiator of the system. So thanks to these three elements combined for virtual antenna technology, characteristics are we have a small antenna form factor able to fit in any IoT device, and then tuning with the tune of the matching network, we are able to cover any IoT protocol within the span I mentioned before, from 400 megahertz up to 10 giga frequencies. And then the main key advantage of this antenna technology is the predictability of the performance, which reduces the design time cycle. So antenna intelligence cloud that we will see in the next slides. So as you may know, the integration of the antenna is hard, but we designed an antenna design journey that we follow as well when we are developing our application or products, and consists in 6 steps. The first step is the feasibility analysis, so the antenna intelligence cloud, and you will be able to assess the antenna performance before any hardware design. So you don't need to put any resource, any engineering resource to the hardware design. So you can make go or not go decisions in the simulation stage, thanks to the antenna intelligence cloud tool. Then when you have met all of your performance requirements, you can go to the design stage with the building of the Gerber file and also the Gerber sanity check. And thanks to the electromagnetic simulations, you can put everything, every component in your design, such as batteries, antenna location, and other RF components such as the RF module, connectors, and so on. So once everything is aligned with your expectations, the performance is okay in terms of simulations and everything is included and considered, you can go to the prototyping stage. And once your device is manufactured, you need to verify that your response is aligned with the simulations. So, you need to verify through a VNA the reflection coefficient of your device. Then, thanks to the tailored capabilities of the virtual antenna, you can fine-tune the response in case some switching, some shifting in the antenna response is made, because when you are in simulation, maybe you forgot some detail or so on, but it doesn't matter, don't worry, because you can fine-tune the matching network and then get back to the desired response. So when your antenna is aligned, in terms of reflection coefficient as well, in the anechoic chamber, you verify the antenna efficiency, and then go to the pre-certification stage. Then, well, you will make sure that you need to fulfill any certification requirements, such as over-the-air test, TRP, and TIS. So I should add that pre-certification test also can be assessed in the first stage of this design journey, because you can evaluate the performance with the total efficiency and the expected output power of your RF module, and test the TRP values through the Antenna Intelligence Cloud report. As I mentioned, the Antenna Intelligence Cloud tool allows you to assess the performance of your device before any hardware design. So let's try this tool. I will invite you to check the QR code and go to the Antenna Intelligence Cloud landing page. And I will, while you are doing this, I will share my browser as well. Okay. Do you see my browser?
Yes, we can.
Okay. So as I said, please check the QR code to go to this landing page, or follow the link above the QR code. And then let's try this together. As you can see here, it is quite easy to use. So you only need to put the communication standard of your device. Let's say, for example, LTE. Okay, you can select for a list of frequency ranges. In case it's not here, your desired frequency ranges, you can also check the others, and then by sliders or writing your frequency range, you can also submit this form. Okay, so please be consistent with your requirements, because you can submit this form in a accurate way. So let's try this range from 700 megahertz up to 2.7 gigahertz. I will set here a 100 millimeters length by 50 millimeters width. I think I forgot to mention, I will follow all of this design journey with this evaluation board. Okay, that it has been tested from the very beginning from simulations with this tool. Also, we made the Gerbers and electromagnetic simulations, and then we manufactured this evaluation board. And we will see in this webinar how simulation performance is matched with the final device. So let's follow this application. For example, let's say asset tracking. Okay. I forgot to mention as well, you can add more communication standard here. So in case you have, for example, 2 or 3 wireless technologies, you can as well add whatever you need to cover. Okay. Then we have as tracking, and then the choose for me. You can select from our antenna portfolio each of the 6 antenna we have, and then you will receive. Let's check, for example, the random extent. You will receive a report with this preferred antenna, your choose one, and then the selected antenna, the antenna selected by us as the best performance choice. So you will have your choice with your expected antenna or your preferred antenna, your choose for me, and then the selected antenna report with the best performance case for your device. Then I complete before the form with my information, first name, last name, the mail, company, region, project name, let's say IoT test. You can also put here estimated annual units, let's say optimistic. And for example, okay. And then we select here the RF model we are using. For example, let's say Nordic. I accept and I in terms of service. And we submit the antenna design request. It will appear an icon like this, and then we will say thank you for your submitting. Wait until a page giving you thank you by submitting this antenna design request appears in your browser. Maybe my connection is a bit slow, but it should appear. Okay, okay. Thank you for your message. Your request has been successfully sent. And you will receive an email like now, when you submit. Now you will receive, it should say you will receive a report with your preferred and selected antenna within 24 hours. Okay, it depends on the traffic load. Okay, so be patient. It may take 1 hour, but also 24 hours. It depends on the traffic load. I should recommend you to submit this form in this webinar. So maybe Ignion considers me as a speaker again, so please do it. So let's come back to the presentation to see what will you get once you submit the form in the Antenna Intelligence Cloud tool. You see my screen?
Yes, now we see the presentation.
Okay. So what will you get? You will receive a report like this. Okay, this is an example. It's not the submit I made. Okay, you will receive the requirements here. Maybe I should. How can I put a laser like a pointer? Do you see the pointer?
Yeah, I see your cursor. Yeah, it's not laser, but it is. It's okay. I can see it.
I'm pointing your requirements.
Yes.
Okay.
Yes, I can see.
Okay.
Yes.
So you will see here your requirements as you submitted. Then you will receive antenna location recommendations and as per your dimension submitted and clearance area recommendation. In the next slide, you will see matching network topology recommendations. and bill of materials. You will obtain, well, the Antenna Intelligence Cloud tool will provide you a bill of materials and then expected performance for your PCB, okay, in terms of S11 in dBs, the reflection coefficient, overturn loss, and total efficiency or antenna efficiency in dBs, okay. Then the last, the last slide or the last page of this report would be general design recommendations for your device. It says general, but it is strongly recommended to follow this because it says clearance area, recommendations, antenna location, optimizing the performance, also material and multi-layer PCB recommendations, matching network path layout recommendation, transmission line RF module location, and row plane layer, okay, recommendation. So be aware that this page say general, but it is strongly recommended to follow this. And let's go to the next slide. So to sum up, I will invite you to go to this Antenna Intelligence Cloud tool, check it by this QR code, fill out the form, and get your antenna design in less than 24 hours. Okay. From all of the submissions in this webinar, after the IoT Creators webinar, we will draw a winner of 1 hour consultancy with Ignion Antenna Expert. Most probably will be me. So good luck. So summarizing a bit this stage, this feasibility analysis, we will add the dual extend covering GNSS, okay, for the next stages of the design, like simulating a design constraint or a design change in the middle of the project. Okay, we add a new wireless standard, and we will see here in the next slide the submit we made with the Antenna Intelligence Cloud tool. Okay, we will receive the trio. We will obtained, sorry. The selected antenna is the Triom Extend covering LTE from 700 megahertz up to 960 megahertz and 1.71 gigahertz up to 2.2 gigahertz. Okay. Matching network topology as well, recommendations, and the bill of materials. Okay, you see here the PCB dimensions. We submitted a 100 millimeters length by 50 millimeters width. Okay, and this dimensions here is for clearance area. Okay, it also provides you a clearance area recommendation. But to sum up a bit everything in the feasibility analysis, and to sum up also the information provided by the Antenna Intelligence Cloud report, the performance of your wireless system is affected by antenna selection, as well the antenna location and the PCB size and its ground plane layer, the clearance area and the matching network topology, and also the paths layout is a thing to be considered. So bear in mind that all of the design recommendations in the report are strongly recommended to follow. Okay. Let's go to the next slide. Well, let me get some water, please. Okay. Once we met all of the requirements before starting anything, any hardware design, okay, once we met all of the performance requirements, we are okay. We are in a go decision. We start to build the Gerber files, and we are in the second and in the fourth stage of this design journey as well. And then we will start building the Gerber files as per design recommendations made. Okay, antenna location, antenna footprint, and feeding line. We will provide you all of these recommendations. Well, clearance area, matching network, just topology, path size, and so on. RF module location, transmission lines, typical 50 ohms, and ground plane recommendations. So this is an example, okay, from the Gerber to the CAD file, okay. In this stage, we will strongly recommend you to review the main design parameters of antenna integration, such as clearance area in all the layers of the PCB design. Not only the antenna layer, this is very important. The clearance area for the antenna, it is very recommended to not only in the antenna layer should be respected, it also in the vertical. No metal materials should be placed or should be put in the underneath the antenna or in front of the antenna. The vertical direction must be also respected as well in terms of clearance. Okay? So avoid metallic components near the antenna. This is my advice, the definitive advice. So while we are building the Gerber file, okay, we are in the third stage, the electromagnetic simulations. So by following the design recommendations, okay, we also been implemented all of the components in your device, such as casings, batteries. You can also, we will strongly recommend you also to put everything in the design in order to follow the antenna performance step by step. So thanks to the tailored capabilities of the built-on antenna, if a change made in the design, you can follow this design with the electromagnetic simulation and then tune the antenna when you are making some changes in the design. So design constraints, design changes, last-minute design changes can be followed, and you can get back to the antenna performance, to the desired antenna performance by fine-tuning the matching network. So I will present you here in this stage typical mistakes made in antenna integration for IoT devices, the electromagnetic simulation results for this evaluation board, and then we will evaluate the PCB size influence on antenna performance, the main degree of freedom when we are maximizing the antenna performance. So here we are, the typical mistakes when designing antenna for IoT. As I said, not considering the influence of clearance area, respecting the clearance area only in the antenna layer, but as you can see in the middle of the slide, the second image, putting the batteries in front of the antenna will drop the antenna performance significantly. I can see it in when I am working with customers, that in a device the batteries is like this in front of the antenna, and by removing the batteries, the antenna performance goes for 10% antenna efficiency up to 50% antenna efficiency. So by changing the batteries, as in the third image, the performance is following the design recommendations and the antenna performance is maximized. So bear in mind, materials in proximity with in the antenna, in the area, in the clearance area of the antenna, casing materials as well is very important to keep in mind that metallic casing will drop your antenna performance, of course, battery placement and metallic screws. Bear in mind metallic screws, because it's a thing that is, well, there are screws, yes, but you have a screw in the, like here, okay, your performance will drop, okay, it's metallic. So bear in mind this. But then we go to the electromagnetic simulations for the example we are following with the design journey. As you can see, okay, in the slide and also in my camera, we follow all the design recommendations made by our team. Okay, in case of antenna selection, the trium extend, we selected the duo for GNSS. We put the recommended clearance area as well, the path layout, the bill of materials, everything is implemented following the design recommendations. And then you can see in the right, in the right of the slide, the S11, the return loss in S11 dBs, and as well above the reflection coefficient graph, the total efficiency, okay, for LTE, 700 megahertz up to 960 megahertz, and as well 1.71 gigahertz up to 2.2 gigahertz, and for GPS. So keep in mind the example, sorry. Keep in mind this example, okay, because we will evaluate the performance along different examples in terms of PCB size, okay? Antenna efficiency is strongly influenced by PCB dimensions, especially in lower frequencies, okay? So let me introduce you the examples we evaluate in simulation, okay? This will be, for example, a good exercise to make by yourself when you are designing when you are designing your IoT device, and you need to decide which is the form factor of your PCB. So we evaluate the L size, is this one. Okay, we reduce the length from 100 millimeters length up to 75, and then the S, the small one, the S size for 50 millimeters length, and then the extra small 30 millimeters length by 40 millimeters width, and then we go to a round PCB around 40 millimeter diameter. So in the graph you can see, in terms of antenna efficiency, 5 different board sizes, and especially in low bands you can see how the performance is dropped in terms of PCB size, and is performing is less affected in higher bands, but it is completely dropped for the smallest one PCBs. Keep size in mind when evaluating, for example, regional certification requirement. We need to surpass some certifications. Keep the PCB size of your IoT device in mind. Okay. So when we met all of the requirements, we have simulated all of the components. When we considered everything, we can go to the manufacturing stage. We build the prototype. We verify the reflection coefficient with the DNA. We fine-tune the matching network if needed. We did it, and verify the total efficiency in the anechoic chamber. So you can see here how the measurements and the measurements for LTE, and the measurements for GNSS, the solid line, our measurements are aligned with the dotted line, which are simulated results with the same bill of materials or the same topology. You can see in the slide is this PCB. It's the same PCB. So as you can see here, by following the design recommendations, following all the steps we mentioned before, you can control the antenna performance along all of the design cycle of your IoT device. So we finish the manufacturing stage. We go to check the certification requirements. Okay, we are in the pre-certification stage, and we perform this example with the 5 example board sizes we saw before, and 2 examples, one for US, most common operator requirements for band 12, from the L size to the round PCB, and for EMEA as well, the most common operation requirements and band 8 and 20. As you can see in the slide, for US, we have a target of 10 dBms, okay, for all of it doesn't matter the size, this is 10 dBm tier P target. And as we can see, the L size and the medium size is easily fulfilling the targets. The small one as well is performing okay, but the extra small on the RAM PCB are barely fulfilling the target. So this is why I mentioned, bear in mind that your PCB size can make the difference, okay, in the design cycle of your IoT device. Then for EMEA, we have 2 targets. There are more strictly implemented for bigger PCBs. We have a 18 dBms target for medium and large size. In fact, in EMEA, we have the small PCBs are considered for dimensions smaller than 50 by 50 millimeters. So smaller or equal, sorry. So the target in 12 dBm is set for smaller PCBs. So as we can see here, 20 dBm for L and M easily cover the target requirements, and for the smaller ones also is fulfilling the design the requirements for the certificate. There are no certification requirements for China and the rest of the regions, but it doesn't matter. Bear in mind that a good antenna performance, so the reflection coefficient and good total efficiency results will save your battery life and will ensure that the communication is working. So if you want an IoT device that is working okay, please follow as well the design recommendations and all the steps mentioned before. So at the left of this slide, you can see the formula for estimated TRP. So this is why I mentioned before with the Antenna Intelligence Cloud tool, we will provide you total efficiency for your earliest stage of your device. So with estimated RF module output power, for example, if you are in class power 3 or class power 5, it is 23 dBms or 20 dBms, you can assess your performance. You can estimate that you will fulfill the design recommendation, the certification requirements, and you can make go or non-go decisions from the early stages of your IoT design cycle. Okay. So once we evaluate everything in free space, we evaluate the performance when it's affected by surrounding materials, such as wood, concrete, human or animal body, and metal. Okay. We put exactly this evaluation board, okay, in a wood wall, and we evaluate that it doesn't affect it very much. So it is okay to place this device in close to wood walls. We evaluate in a concrete wall, and we state that affects antenna performance in higher bands, and when it is closer, affects a lot to the lower bands. So sorry, I forgot to mention, this test is made for 5 cases, okay, when the wall is placed 20 millimeters, 15 millimeters, 10 millimeters, 5 millimeters, and touching, okay? I forgot to mention that, it is very important. So, because, for example, for human and animal body, the performance a lot, no matter what is the distance. So locate your device with the minimum body influence as possible. For example, here on the ankle, okay? And I think it is not necessary to be an RF expert to know this. Metal affects a lot the antenna performance. So the advice is keep metal at distance as much as possible. And then if you know that you will implement your device with surrounding metal around your device, retune the matching if metal is close. So analyze your device with the presence of metal, okay? Because I see it a lot of times when I'm working with a customer device, that the antenna response in free space changes when you are placing like when you place a metallic wall or metallic patch, yes, close of the device. So bear in mind that you will you need to analyze your device with surrounding materials. Okay. So this is an example and a customer success story following the design recommendations and the design journey that I explained before, from the electromagnetic simulations and the Antenna Intelligence Cloud tool with simulated results, antenna performance. And then we go to the Gerber review stage. We evaluate the Gerber. We check all of the design recommendations and all of the design constraints. And then with the final device, we evaluate the performance with everything, with the casings, with the batteries. And you can see here, I see my camera. And okay, no. We evaluate with the casings, and we check the performance with the matching network, also this, and we check also the RF module location and so on, and also the clearance. Okay, and this would be the performance. You can see, in fact, you can see this this example in the application note for website. So I invite you to check the website in the application note section for the 3MX10. This is the Thingy 91 application note, and you can see this table. Okay, so if you want to check this story, I invite you to go to the website. To summarize everything, this is the design journey presented by Ignion. you can go to the landing I shown you before to start your design. And in the electromagnetic simulation stage, in our website we have the design pack info where you can find all the step files that you can import all of our antenna portfolio in your CST simulator. We are planning to put as well the step files for HFSS or ANSYS simulator, but it is not yet. So be patient or contact me or contact the info mail. Okay. Then for the Gerber review, find the matching network service and the pre-certification test. I will invite you to the design center to check our engineering support service, so we can guide you along from the very beginning of the design to the final device and the pre-certification stage. So this is everything. Do not forget to request your Antenna Intelligence Cloud, and if you have some questions, thank you.
Thank you very much, Jordi, for your presentation. And yes, we do have some questions, so maybe I can read them to you and we can answer them together. So first question is, so you mentioned the virtual antennas. So what is the limitations of your virtual antennas? Like, is it limited by the maximum power or something else?
The limitations of virtual antenna is, I would say, the ground plane layer, and also the frequency bands. The frequency bands from 400 megahertz up to 10 gigas, we are okay, but lower or higher, it will be a limitation for us. So within this range, every wireless technology is working very well with our technology.
Okay.
But mainly the ground plane layer is the limitation. So very small, you saw it in the presentation, very small, very reduced PCB dimensions is a thing, but not only for virtual antenna, for every antenna technology.
Antenna design, yeah. Okay, thank you. And another question is, so how efficient is the virtual antenna works for a PCB size of 20 millimeters to 300 millimeters or less? Any special consideration to improve performance other than increasing PCB size for the ground plane? It is parallel to what you described. So it's like a very small PCB. So how efficient is your virtual antenna for this specific size?
It is a very small PCB, but I hear 300 millimeters.
Yeah, you can also see the questions in the screen, I believe. So yeah, I mean, because like that will be easier, but it is 20 millimeters plus 300.
Let me check it. Well, in fact, the Antenna Intelligence Cloud tool is limited. I think the nano is the limitation, and it is a 3 millimeters length. So I think the limitation in terms of viability, let's say,
can I interrupt you? Sorry, because I guess there was a typo in the question, and the person asked the question.
20 millimeters.
20 millimeters to 30 millimeters.
Yes, I saw a lot of PCBs with these dimensions. In fact, as I said, the Nano extend, for example, it is a 3 millimeters length by 2 millimeters length, high width. Sorry. So the limitations are, I would say, a bit lower than this.
Okay. So do you have any special consideration recommendations to improve performance for those small PCBs?
Any special constraints with the virtual antenna? No, the ground plane layer is the main radiator of the system. So if you follow the design recommendations, for example, maintain the continuous ground plane layer. I think, for example, with the example with the 20 millimeters per 30 millimeters, if you follow the recommendations in terms of ground plane layers included in the report, there are no design recommendations for further than this.
Perfect. Thank you so much. Another question around another topic. So can you elaborate on the clearance area? How can I calculate how much clearance area that I need?
Okay. Well, normally, I would say larger than the antenna dimensions. Okay, but you can also go to the user manual in our website, and you can, for example, check the optimum clearance area. But you can also send us an email, and we can elaborate a better answer with the design of this customer. So you can contact us by email with any free of charge, I would say, or submit an antenna intelligence cloud tool, and the antenna intelligence cloud report will recommend you the best clearance area for your device.
Okay.
But if the customer is talking about the minimum, I would say contact us via mail with the info, and we can evaluate your device.
Okay, but at least as big as the antenna itself is, I believe, a good rule of thumb.
Yes.
Okay, another question. Is there any standard size for antennas so it can be possible to replace when PCB is already produced?
Is there any standard size for antennas?
So it can be possible to replace.
So in case the PCB is, well, we have a lot of cases with PCBs already produced, and the design stage or the engineering team has decided to change the antenna, and we faced a design, a matching network design, or a IoT device design with design constraints in case of space. So as I mentioned before, the antenna portfolio goes for a very small antenna to a large antenna. So I think, yes, there is no problem to replace an existing antenna in a design when a PCB is already produced.
Okay.
Bearing in mind the design recommendations, for example, in case of clearance antenna. So if any change can be made, maybe it will work better.
Okay, thank you. So there is an upcoming question. I'm not sure if I understand it correct. So Gonzalo, please, if there is a misunderstanding, please text me from the chat and I will re-ask your question. But it asks, can we have components in the ground plane? Can we have the components in the ground plane that we declared, or only the RF module? So in my understanding, can we have another components rather than the RF module in the ground plane?
Yes, of course. The only issue is to place component, for example, in the clearance area or in the near of the antenna. But yeah, the antenna layer, let's say, can include other RF components and other non-RF components. So no problem with this.
Okay, I hope this answers these questions. If not, please feel free to follow up in the chat. Okay, then you also mentioned the metallic screws affecting the efficiency. So what are the alternatives over the metal screws, like plastic holders, or what can be the alternative to the metal screws?
Well, it is not strictly mandatory to not use metallic screws, okay? It is strongly recommended to place these metallic screws away from the clearance area. But if you need to put a screw, let's say, in the very near of the antenna, I would recommend you, for example, a plastic screw. I saw a lot in design, in matching network services with other customer devices. But, well, this is like, if you mandatory need to put a metallic screw in the near of the antenna, we can evaluate in our lab the performance, and most likely the antenna performance will perform okay, but it is only a recommendation. If you want to improve as much as possible the antenna performance, this is a constraint.
Okay, thank you. Another question. So, are the antenna patterns generated from your simulations with radome or without the radome? So the housing. So your simulations is your simulations include the housing, or it doesn't?
It can be. The Antenna Intelligence Cloud report doesn't include radiation pattern, but or simulation services. Yes, it includes radiation pattern it can be with free space, It depends on the demanding of the customer, but also it can be with the device, of course.
Thank you.
If you, for example, if you send us a step file with everything included in the design, we will provide you the results considering everything in the device. So yes.
Okay, so they are quite individual, the recommendations. Yeah. Okay, so there's a question regarding your slides. In the slide 23, the certification part, is the TRP part of the US EU certifications, and what was considered for the module transmission power based on shown figures, So maybe if you can go back to your slide 23, slide number 23, it would be easier. Yeah, so here. So the question, I repeat the question, then, is the TRP part of the US and EU certifications, and what was considered for the module transmission power based on the shown figures?
Yeah, based on the shown figures, the output RF the output power for your RF module, we consider 23 dBm. As I mentioned, I think I mentioned before, you should test your estimated TRP in case you don't have a produced prototype. You can test the TRP, but you should consider the output power. So there exists two classes of power, I think, as far as I know. Okay, class power 3 or class power 5, and test the performance with 23 dBm for one class power or 20 dBm for another class power. So here we test the TRP dBms, the 19, 15, and 10 with 23 dBm output power, and with the total efficiency of this evaluation board.
Okay, thank you.
And I think, yeah, I answered the full question.
I think so, yeah. I think this was the question. Then I move on with the other question. Can you achieve circular polarization? I guess with your antenna.
No, all of our virtual antenna products are linear polarization, has linear polarization, especially in the low bands. And as long as you go to high frequencies, it is mainly linear polarized.
Okay, thank you.
It might change a bit, but it's mainly linear polarized.
Okay, as of now. Another question is a bit hard, I believe. Why you choose the name it virtual antenna? How your antenna is virtual? I don't think that you choose it, but maybe you have an idea over that.
Okay, let me remember the marketing class. No, the name of virtual antenna is because our antennas are non-resonant. It means that it is not only the antenna, the red part, it is a system. The antenna works thanks to the matching network, but also thanks to the ground plane layer, being a non-resonant system, and your PCB is radiating with the ground plane layer. But that is a virtual antenna, because the red product is not only the red product, the antenna is the system. Well.
Okay, perfect. Thank you. Another question. Sorry. Can I use single virtual suitable antenna for both cellular and GNSS? If yes, should I design separate matching network for every band of frequencies such as GNSS, GSM, narrowband IoT, and LTE-M? I think it's a good example. Thingy91 is a good example for that question.
Yes, yes. I will recommend you to go to the application note section. If not, Madhu, send me an email and I can explain you a bit further. But yes, you can evaluate for example, the Triome extend in a multi-port configuration. But yes, you need a matching network for cellular, and then you need a matching network for GNSS. Then an alternative will be an active matching network with a single port. You can cover cellular and GNSS, but this is another word. But it is included it is mentioned in the Thingy91 application note. Yes, in fact, we have application note for the Triome extend with separated ports, separate matching network for cellular and GNSS. And then we have the Thingy91, which is the perfect example for, as I mentioned, 3MX10 in a single port configuration covering cellular and GNSS as well. But if this is not enough, please contact me by email and we can further discuss it.
Perfect. And the last question in the Q&A is in parallel to the previous one. So are there specific design principles to keep in mind when designing a PCB with multiple radio technologies, like the one with GNSS and the cellular antennas? And how much does adding extra technologies affect performance of each individual technology?
Wow, this is a good question. Okay, step by step. Let me read again the question.
Please.
Okay, I would say no for the first question. There is no extra design principle to consider, as long as clearance area recommendations and so on. I think you need to follow exactly the same design recommendations. But yes, of course, you will affect it by coupling effects. But how much does adding extra technology affect performance of each individual technology? Well, you will affect it by, as I mentioned, you will affect it by the coupling, and this can be evaluated with our support technical team. But you can as well, you can submit an antenna intelligence cloud tool for multiple antennas. And in case you need a single antenna for multi-port configuration, our support technical team can help you with this. So as I said before, if you are not satisfied with the answer, send me an email and we can further discuss it.
Thank you. There is one or two last questions in the chat, so maybe you can also have a look, Jordi, and I will try to read it. So have you had studies done for antennas performance alongside polycarbonate and polyurethane type materials and seen results similar to the concrete and metals and etc.? So yeah, like you show examples with antenna on a concrete surface or antenna on a metal surface. Or do you also have studies over the polycarbonate and polyurethane type of materials or not?
I think polycarbonate materials is the last thing that you will consider in your design. I saw in other customer devices that polycarbonate may shift the design, the antenna response a bit, but it will only add some losses to the system, so it might be affected by a total efficiency. But let me go back to the material section. More or less, and from my experience, it will be the same as the good example. It will add some losses to the system, and that's it. Polycarbonate doesn't affect a lot the antenna performance. And the next question: do you also support antenna for 900 mm such as the LoRa? Yes, we have also antennas for LoRa. In fact, from 400 megahertz up to 10 gigas, we have antennas for that. Any disadvantage you could mention compared to LTE antenna perspective? I think I don't understand the question.
So it is asking if the LoRa antennas has any disadvantages compared to the LTE or NB antennas.
I think the only disadvantage I can see now, as I mentioned, we can discuss it by mail or you can call me. I think is the LoRa is a narrow band, and it is the perfect example for an antenna. Covering a single narrow band is the perfect scenario for your antenna. And I think the main disadvantages for LTE will be covering a multi-band solution. It always brought the performance comparing with a single narrow band. So I think this will be the main disadvantage, the multi-band issue.
Okay. Thank you so much. And in the meantime, we receive another question from the Q&A. We will not let you go, Jordi.
Of course.
Since we still have more time, I would like to ask that one from Oscar. So what is the performance of your antennas in wearable devices? Is it necessary to have any other consideration?
Well, in fact, we have several customer devices here regarding wearable devices. And I think the only consideration you need to follow if this wearable device will be implemented in a human body. So as I said before, and this slide is based perfectly, locate the device or consider locate the device in a minimum body influence, such as here the ankle of the arm. But yes, in case you are considering virtual antenna for your wearable device, I will recommend you to send us an email or to submit an Intel Intelligence Cloud tool and test us, please. We'll be glad if you consider us for your wearable device.
Perfect. Then I believe we are through with the questions. So thank you so much, Jordi, for your presentation and for those great Q&A session.
Thank you so much for the opportunity, and I hope you enjoy this webinar as well as I did.
Thank you very much for being here. And thanks for everyone joining for the session as well. Tomorrow is our last day with the NB-IoT and LTE-M Learning Week. And we will have 2 sessions around IoT protocols where we do a technical deep dive into different protocols. So I hope to see everyone there. And until then, I wish everyone a very good evening. Goodbye.
Bye-bye.